Welcome back everyone. Now I have finished all the tedious placement of and also almost route all the analog parts of this atomic triad. That's almost finished everything. I have only the summation here left. This should be placed, and the LED, but otherwise here we have the summation operation amplifier, and here we have the ADC. That's everything for the atomic triad. And then I need to place also the logic controller, the FPGAs and some USB connection and so on. So I use AI agent for placement of repetition placement, because easy EDR have not that tool, but I simply make a template. These signals will re-enter the matrix, and there you see these lines is because it will, the first layer will enter the sigmoid functions and then reroute back into the second layer after the sigmoid function. And the sigmoid function is purely analog as well. For example, here we see sigmoid function consists of this, and I have simulated that in LTSpice. And I have made a special trick in this math to not introduce another hardware. Extract the slope of this these activation function, so I can get the derivative here, so I can propagate that up through the first matrix. And I was argue with the AI chatbot, because the chatbot was take the standard back propagation math, but that was not correct. So I was instead of add even more analog hardware, I do a trick in the math to jump over the derivatives up here. So the only thing extra in terms of ADCs is this one, and this only need the short measurement window, so it will idle most of the time. I work a lot of thinking about how do the architecture, how do I make the architecture with as few components as possible, even if I want the neural network to be inbuilt the matrix itself, so it runs purely in the analog domain for compensation. That's the goal. And here you can see the 3D layout. So here we see the sigmoid function output of the matrix 8, and here we see the sigmoid function output from the matrix 3, and above that we see the TI current to voltage. The only left is the summation here. Stay tuned.